I'm Anil Kumar. Welcome to my series on quadratic inequalities. Here we have 4 examples. Question number 1 is solve x plus 3 times x minus 1 less than 0. Then we have 2 minus x times x minus 3 greater than 0. So those were the factored form. Question number 2, we are given the quadratic equation where you need to factor. Both these equations are with the coefficient of x square as 1. Question number 3 is of the form of ax square plus bx plus c and difference of squares. Question number 4, find the integer values that satisfy the following inequalities. Now in the first 3 questions you need to find the real numbers, right? And question number 4, integer values. Now these 2 questions might need calculator, but the questions 1 to 3 are without calculator, correct? You can actually pause the video, answer these questions, and then look into my suggestions. Let's begin. Question number 1. We need to solve x plus 3 times x minus 1. Now straight away, what we will do here is we'll graph, right? Now when I say that x plus 3 and x minus 1 are 2 factors, we can actually find the zeros, right? So we need to find the zeros. Zeros are at x equals 2. This is 0 at minus 3 and the other 0 is at 1, correct? So you can mark these zeros as minus 3 and 1. Now second thing, we need to look into the coefficient of x. So when you open this, we know the coefficient of x is positive. So we say positive leading coefficient. That means the graph will be facing upwards, right? So let me sketch the graph now, joining these 2 points. So we can actually straight away just, because of inequality, we need not even bother about other points. Now what do you notice? When is the function less than 0? That is part of our solution, correct? So as you can see from here, the graph is below the x-axis from the values from minus 3 to 1. So that becomes our solution, correct? So we are going to write the solution of this as the value of x is greater than, because it is greater than, right? So we have to take greater than, not equal to, minus 3. So minus 3 is not included and is less than plus 1. Is that clear to you? So that is how you can actually solve the inequality using a graph. Perfect. Now in the second question, we will use a different method. So we'll actually, in the second question, analyze intervals. So what you notice here is that this particular function has 2 factors, 2 minus x and x minus 3 greater than 0. Now some of you can also do something like this. Since x is minus, we have to factor out minus outside. So it becomes minus of x minus 2. It's a good idea. Times x minus 3 greater than 0. Now purposely I am taking these steps so that you understand how to solve inequalities in general. So when we have minus here, then if I multiply with negative on both the sides, then this of course becomes positive, right? But the inequality direction changes. So negative thing was greater than 0, positive thing has to be less than 0, right? So that is a very important criteria. Now it is not must that you should do this, but I have shown you these steps since it is important to understand. Now while solving inequalities, graphical method is very fast. So preferably, if no restrictions are given to you, you just use graph and get your result. I'm going to discuss with you here how to do it with intervals, since it is also a good method to work with. And at times in the questions, it is specified to work with or to solve with intervals method. So you have no choice, correct? So how do we work with that? We have now two factors. One is x minus 2 and the other one is x minus 3. Now these two factors will give you zeros, right? So the two zeros will be at x equals to 2 and at x equals to 3. We can write this here like x equals to 2 is a 0, x equals to 3 is also a 0. Now these two zeros divide the whole interval into three regions. This region is, let me use another ink. We'll say this region is when the value is of x is between minus infinity to 2, right? So to let's write minus infinity to 2, right? So brackets means not included, and this is between 2 to 3, and then we have interval which is from 3 to infinity, right? And these interval, which is minus infinity to 2, 2 to 3, and 3 to infinity, will take test points, right? So I'll write test point here. So we could take, let's say 0 as a good test point in this interval. We could take 2.5 here, and here we could take 4 as our test point. Now, if x is 0, x minus 2 is going to be negative. If x is 2.5, x minus 2 is going to be positive, and for 4 also it is going to be positive. As far as x minus 3 is concerned, it will be negative for 0 and 2.5 and positive for 4. So now the product of this particular function, which is 2 minus x times x minus 3, is going to be positive because of two negatives, and this is going to be negative, and here it is going to be positive. Since we are interested in this particular equation, which is these factors when multiplied should be less than 0, means negative, right? So that becomes our answer between 2 to 3. So we get the value of x as greater than 2 but less than 3. Is that clear to you? So that is the answer for this particular question. You can see that if you would have sketched a graph, right? So whether you sketch it with this function or with that, let's sketch the graph for this function. We are saying that now we have made it positive. We are looking for less than 0. The graph will be a parabola opening upwards like this, right? So the interval which we are talking about is this, correct? Between 2 to 3, and you get immediate answer. So from the very first question, you understand two techniques of solving quadratic inequalities. One, sketch the graph and get your answer within few seconds. Second, analyze the interval and get the answer in few minutes, right? Now let's continue and see how to solve the questions when factored form is not given to us. So now we have x squared minus 29 plus 28 less than 0. So we need to factor, right? So we are looking for product of 28 and sum of minus 29. So 28 could be written as 28 times 1. Since we need a negative sum, both should be negative. So I could factor this as x minus 28 times x minus 1 less than 0. Now we'll use the graphical methods because that is much faster, right? So basically we have two zeros here. One is at 28, the other one is at 1. So the graph is opening upwards. It will be kind of like this, right? Well, it is not at all to the scale, but it serves the purpose. So this is at 1, this 0 is at 28. We are looking for values which is within these two intervals where it is negative, and therefore the answer in this case will be that x is greater than 1 and less than 28, correct? Now you can actually pause the video and do the next question. X squared minus 4x minus 21 could be factored since 21 has product of 7 and 4, right? And if I take 7 as negative, 7 and 3, I'm sorry, 7 and 3. If I take 7 as negative, then minus 7 plus 3 is minus 4. So we could directly factor it. So what we get here is x minus 7 times x plus 3, and that should be greater than 0. Sketching this, what do we get? We get a parabola which will be opening upwards One 0 being at minus 3, the other one at 7. So it will be something like this, right? Where the points for us are minus 3, the zeros for us, right? And 7. And from here, we want greater than. That means we are looking for less than minus 3 and greater than 7 as our answer. So here the solution will be x is less than minus 3. You can say union or you can write or and, right? Union is better word. And x is greater than 7. So that becomes the solution for question number 2b. So I hope the concept is clear, right? Now let's solve question number 3. Minus 6x squared minus 13x plus 28 less than 0. You need to factor this. The coefficient is not equal to 1. It is minus 6. So to factor, we will look for product to be what? Product should be minus 6 times 28. And the sum should be what? Sum should be minus 13. Now how do we get these numbers? So let us also learn a technique to do so, right? So here is a very good method of doing it. You know, we are looking for a product of 6 times 28, or you can factor them, right? So you could factor and write this as like 7 times 4, right? And here you get 6 as 2 times 3. Now, that gives you a combination of numbers to work with. You're looking for a product which will definitely get with these factors, but more important is to look for the sum of minus 13, which could be very tricky. Now, if I take 7 times 3, 21 as one number, and 4 times 2, 8 as the other number, then do I get minus 13? Right? That is what we have to see, right? So if I do that, do I get minus 13? That is what it is important. Yes, we do, right? So I will use 7 times 3 as one number, which is 21. Now, since we need negative, bigger number will be negative, right? And the other number should be 4 times 2, 8, correct? So these are the critical numbers which can help us solve the given inequality. I hope you got the idea. So this is a good method of doing it. So now we'll substitute minus 13 with these two numbers. We'll write this as sum of 21x and minus 21x and plus 8x, right? Now in the first two terms, I can take minus 3x common. So I have x minus 7. Minus and minus becomes positive. In the second, less than 0. In the second, we can take 4 common, right? So we get x plus 7 in the bracket. Now x plus 7 is common. And here we have minus 3x plus 4 less than 0, right? So these are the 2 points which we have got. Now if you sketch a parabola, how will it look like? Now see, if you do not factor out this negative, sometimes you may do a mistake, thinking that there is positive here and you may draw a parabola in this fashion. You'll get a wrong answer. Therefore, I insist that whenever you have this quantity, it is better to factor it out. So we'll actually factor it out and then sketch the graph, right? It makes sense. So when you factor minus, then you get minus x plus 7. And here we have 3x minus 4, right? Less than 0. Does it make sense to you? But this minus tells you that zeros will now, the parabola will now open downwards, right? So what are the zeros for you? X equals to minus 7 is 1 0. The other 0 will be at x equals to 4 over 3, right? Slightly more than 1. But the parabola opens downwards. That is important to understand. So the graph will be something like this. Do you see that part? And since we are looking for values which are less than 0, the solution will be what? The solution is going to be on the left side of the first 0, which is at minus 7, and on the right side of the second 0, which is at 4 over 3, right? So The solution for this will be that x should be less than minus 7 union x should be greater than 4 over 3. Does it make sense? So that is how we are going to solve this question. I hope the method is absolutely clear. It's slightly difficult than the previous questions. Now let's look into part B, which is 4x squared minus 9. This is difference of squares. You could think like this, right? 4x squared minus 3 squared greater than 0. So I could write this as 2x plus 3 times 2x minus 3 greater than 0, right? So we have two zeros at x equals to plus minus 3 over 2, right? Those are our zeros. The graph for this function will be opening upwards. And it has even symmetry, right? So it will be like kind of like this. We are looking for something greater than 0. That means the output is this inequality solution, right? So we get x as less than the first zero, which is minus 3 over 2, union x greater than 3 over 2, right? This one is 3 over 2. Perfect. So that is how you get the solution for this particular inequality. So I hope till now it is absolutely clear. So we have taken quadratic inequalities where the solution was in the set of real numbers, right? So here we are considering x belongs to real numbers, correct? Now we'll take a short break, after which we'll look into the inequalities solution where the solution is going to be the integer values, right? Not the real numbers. I would like you to copy this question, try to solve it. Meanwhile, we'll just take a walk, come back and see in the neighborhood how are the deers doing, and then get back to this question. I hope you will enjoy this video also. I hope you enjoyed the video. We had a light snow. Well, the animals are doing well, and now spring is coming, so everybody is getting ready for the real good season. Let's continue with our solution. The question number 4 here is, find the integer values that satisfy the following inequalities. Integer values, right? Not real numbers. Okay. A, minus x squared plus 2x plus 3 less than equal to 0. So as I suggested, we should get rid of this minus first. So we'll multiply by negative all these numbers. So we get x squared minus 2x minus 3 greater than equal to 0. That is kind of important to understand, right? Now, can you factor this? 3 times 1 is 3, and when you add them, you get minus 2 if one of them is positive, right? Okay. So the bigger number has to be negative. So I could write this as x minus 3 times x plus 1 greater than equal to 0. So we get our inequality in factored form. So that is kind of key, right? So now let's try to sketch this graph. We have two zeros here. One zero is at x equals to 3. The other one is at x equals to minus 1. So these are our zeros. Zeros are part of solution in this particular case, right? Since it is greater than equal to. Parabola is going to open upwards with a 0 at minus 1, the other one at 3. So that becomes your parabola, right? So here we have minus 1 and the other 0 here is at 3. Since we are looking for points outside 0, that means what? So that really means that everything, so x, so there are a lot of numbers, right? Now how could you represent this as your solution? That is sometimes a challenge, right? It is not just numbers in between. So what you could say is that x belongs to integers, right? X belongs to integers where x is not equal to, so we can say x is not equal to whatever is in between. Does it make sense to you? So it's not equal to 0, not equal to 1, and not equal to 2. That becomes the solution for the given question. All other numbers, right? Since we are looking for greater than equal to 0, so all other integers will satisfy this equation. Only these integers will not satisfy this condition. Does make sense? At -1 and 3 will get equal to 0, so that is also a part of solution. Is that clear? So it's a thinking question. I hope you understand and appreciate how we have got this solution. Now let's take the next one. Now in the next one, we cannot factor it easily. Well, you might, but we cannot. So we will use the quadratic formula. So let's find the zeros using the quadratic formula. So x is equals to minus b. Let me write down, so minus of b will be minus 60, right? Plus minus b square, which is 60 square, minus 4ac, that is 4 times a is minus 4.9 times 3, right? Divided by 2 times a, which is minus 4.9. Does it make sense to you? So what we have done here is we have written a quadratic formula. Let me explain this. If our equation is ax squared plus bx plus c equals to 0, in that case x is equal to minus b plus minus b square minus 4ac over 2a, and this part is in square root. So that is the quadratic formula. So in our equation, b is 60, a is minus 4.9, and c is 3. Use the calculator to calculate this answer, right? So we have within square root. Now this negative and negative becomes positive, so I'll just make it positive, right? So we have 60 squared plus 4 times 4.9 times 3, which is equal to some number. We'll take square root of this number, right? And that gives you, let's rewrite, minus 60 plus minus 60.48 divided by minus 9.8, right? So this equation normally we use for a parabolic path when you throw something or when something is short. Okay, so that is what you get. And clearly we are looking for two answers here. So one of them will be you add them and divide by this, right? So this is 60, sorry. So let's first add them. So we'll have both negatives will become positive. So let's add 60 to this, and then we'll divide by 9.8. So this answer which we get is 12.29, correct? The other value will be negative. Let's get that answer also, which is 60 minus 60.48 divided by 9.8, right? So that gives you negative 0.04. Okay, so these are the two values for you, correct? So basically, if you sketch it, what do you get? Now, in this particular case, if you sketch it, you will get something like this. At 0, it is 3, right? So it's kind of going something like this. And this negative means this place. So we are looking for integer values. This point is 12.29. So what are solutions? Solutions should include 0 also, correct? So in this case, we get our solution as the values will be 0, 1, 2, 3, up to 12, correct? So all these integers are part of our solution in this particular case. Perfect. I hope that is clear. So there are 13 solutions, right? Sometimes we can just ask you, how many solutions will this have, right? Think like this. A multiple choice question, how many solutions? In that case, our answer will be there are 13 solutions, include 0 also, right? So it could be placed in a multiple choice question as a very critical question from many test point of views. So in this set of videos, I hope you learned the technique of solving inequalities when it comes to quadratic equations. So we actually began with these 4 questions, and with the help of their solution, we have understood many methods. If you are given in factored form, the best way is to sketch your graph, right? So once you sketch your graph, in that case, you know your zeros. And if it is saying less than, that means the solution is this. Does make sense to you? We also saw that if there is negative here in between, the graph will be upside down, right? So in this case, when you find the zeros, we are looking for something which is greater than, that means the solution will be in this interval. Does make sense to you? So that is how, using graph, we can easily find. However, if specified, you could use the intervals method and also solve, as we did part B. Now, interesting questions here are when you want to find integer values. We showed you how to write the solution when there are many solutions, right? So we had infinite solutions in this case. And we showed you how to write those infinite solutions in the form of a set form. And here also, we actually emphasize that 0 was an integer which is part of our solution. And if we ask for number of solutions, that could be a part of your multiple choice question. In that case, include 0 while counting the numbers from 0 to 12. So I hope with this you learn. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.